Okay, so question number 7 from M1 January 2019 IAL. Connected particles. There's two particles, A and B, have masses m and 3m respectively, as shown in the diagram here. And the particles are attached to the ends of a light inextensible string. Particle A is held at rest on a rough horizontal table. The coefficient of friction between particle A and the table is 1/5. The coefficient of friction over here is 1/5. Just write that down. Okay. The string lies along the table and passes over a smooth light pulley that is fixed on the edge of the table. Particle B is at rest on a rough plane that is inclined to the horizontal at an angle alpha, where tan alpha equals 4/3. So tan alpha is equal to 4/3, as shown in figure 4. The coefficient of friction between the particle B and the inclined plane is 1/3. So here you have a coefficient of friction for B is 1/3. And this is for A. The string lies in the vertical plane that contains the pulley, a line of greatest slope of the inclined plane. The system is released from rest with the string taut, and B slides down the plane. So it moves this way when it's released. Okay. Given that A does not reach the pulley, find the tension in the string. Okay. So let's look at all the different forces here. And these kind of questions, very clear, very important for you to draw clear diagrams showing the forces acting on the particles. So of course the first thing we'll do, let's start with A, is we'll consider the weight which is acting straight down, and its mass is m, so its weight is going to be mg. Okay, you also have the tension in the string that's pulling it along. Now, as it's moving towards the left from this diagram, you can see that the friction is going to act in the opposite direction. Okay, it's moving, so there's going to be friction acting, and it's going to act in the opposite direction to the movement of the particle. Friction always tries to oppose the motion. Okay, we also have the reaction force, which is important when we've got friction acting, which acts straight up in this case. And those are the forces that are acting upon this particle here. It's accelerating in that direction towards the left here. Now particle B, again you've got its weight, it's acts straight down. This time its mass is 3m, so its weight's going to be 3 mg. You have the tension acting upwards, well, along the inclined plane, pulling up. Okay, and as it's moving down the plane, the friction that's acting is going to act up the plane. So the friction here, so I'm going to call this friction for A, and here I'll call this friction for B. They will be different. Okay, so we also have, because we're going to be dealing with something on an inclined plane, we have to show the components of the weight. Well, first of all, the reaction force acts perpendicular to the surface. Okay, so that's the reaction force acting up here. But the weight, we're going to resolve it perpendicular and parallel to the plane. Okay, so perpendicular and parallel to the plane. So there's a component of it acting down the plane and a component of it acting perpendicular to the plane. So this will be 3 mg. Now this angle here is alpha. It's the same as that angle here, from similarity. So this is 3 mg. Now as to resolve the force 3 mg parallel to the plane, you've got to move away from the angle alpha. This is going to be 3 mg times sine alpha. And as to resolve the force perpendicular to the plane, you've got to move through the angle alpha. You're going to write this as 3 mg times the cosine of alpha. If you move away from the angle, it will be sine. If you move into the angle, it will be cosine. Okay, so those are all the forces now acting upon this particle. One thing I'm going to deal with is the fact that it says tan alpha equals 4/3. Now, it's for us to find the angle alpha and then use that, is going to be a bit unnecessary. What you need to do, the best thing to do here is to find the value of tan alpha, is 4/3. So therefore we can make a right angle triangle and its sides will be 3, 4 and 5 by Pythagoras. So we can say that the value of sine alpha is 4/5, opposite over hypotenuse, and the value of cosine alpha is 3/5, which is adjacent over hypotenuse. So you've got some exact values to use rather than finding what the size of the angle is and then have things rounded to decimal places. This makes your answers much more exact, and sometimes they do ask for exact answers, so you should understand how to do this. Okay, that's what they intend when they give you an angle as a fraction of a ratio of an angle. You have to, it's best always to find the other angles in terms of an exact ratio as well. Okay, so now it's asking us to find the tension in the string. Now in all these type of questions, okay, what we need to try and do is we need to try to resolve forces in the direction of motion and perpendicular to the direction of motion. Okay, so let's start with the easier one, which is A. There's less forces acting on it. It's on a horizontal plane. Let's start with A. Okay, now if you look at A, you've got, it's moving towards the left here. So we can say that if we resolve the forces parallel, well, horizontally basically, you can say T, that's the force acting in the direction of motion, minus, and you got FA, which is the friction acting on A, and that's equal to the resultant force, which is MA. Okay, so you got M times the acceleration, which we have to find. Okay, this is using the equation F equals MA. The resultant force is equal to mass times acceleration. Okay, so that's one equation we've got. Now we know the acceleration here and here will be the same, and the tensions will be the same in both cases. Alright, but what I can do here is I can find out what FA is, because we know that it's moving, so the frictional force is equal to the maximum value, which is mu r. As it's moving, friction has reached its limit. It's a limit. So what we're going to do now is we're going to resolve perpendicular to the plane to find what r is. Now in this case it's pretty simple. R is equal to mg. So R is equal to mg. So therefore the friction force acting on A is mu times R. Now the mu, coefficient of friction for the surface where A is on, is 1/5. So it's going to be 1/5 times mg. Okay, so the frictional force at A is 1/5 mg. Okay, so we can say this equation becomes T minus 1/5 mg equals ma. So that's an equation now that I've formed from considering particle A. Now I'm going to consider particle B. This time I'm going to resolve going down the plane as the particle is moving down, and also perpendicular to the plane. Okay, if we consider the forces acting as it's going down the plane, okay, you've got the force in the direction that it's moving is 3 mg sine alpha. So you have 3 mg times sine alpha, and then you got minus the tension in the string, and you also got minus the friction acting at B, the particle B, and that's equal to ma. Those are all the forces acting that parallel to the plane. The component of the weight acting down, the friction acting opposite from the direction of motion, and the tension acting up the plane. Okay, so we have that's equal to ma. Now here the m is 3m. The mass of the second particle here, B, is 3m. So it's 3m, and the a here is the same as the a in the first part of the question. Okay, so now we know what, well, we can now work out what FB is. So to do that we have to resolve perpendicular to the plane, because we need to know the reaction force for that. So we got R is equal to 3mg cosine alpha. So if we resolve up the plane, R is equal to 3mg times cosine alpha. Okay, so we know what cosine alpha is. Okay, cosine alpha, as we worked out here, is 3/5. Okay, so we can say R is equal to 3mg times 3/5, which is 9. mg over 5. Okay, so the friction acting at B, therefore, is going to be mu times R. Okay, so the mu in this case for B, as we were told in the question, is different. It's a third. So you're going to have a third times 9 mg over 5, which gives you 3 mg over 5. Okay, so I'm going to take some extra space down here. You guys would have to turn over the page, but I can make it longer. So now I can put these values in to this equation up here. So I know that sine alpha is 4/5. Okay, as we can see from up here, sine alpha was 4/5. So I can say now that if I'm taking this equation and filling all the details in it now, we have 3 mg times sine alpha, which is 4/5, minus T, which we don't know, minus the friction at B, which is 3/5 mg, 3 mg over 5. Okay, that's equal to 3 ma. So let's just simplify this a bit. If we simplify this, you're going to have, that's 12 mg over 5 minus 3 mg over 5 minus T equals 3 ma. So that's 9 mg over 5 minus T equals 3 ma. So that's now my second equation. Now let me bring the other equation down here as well. The other equation was T minus a fifth mg equals ma. So you have T minus a fifth mg equals ma. Equals ma. Alright, so here we have two equations which we can now use simultaneously. So if I'm asked to find what here? The tension in the string. Well, it's easy for me actually to first to find the acceleration, I guess. Okay, we could find the tension in the string, I guess, if we multiply both of these by this. I'll take this one and multiply by 3. Okay, in that case I'll get 3T minus 3 mg over 5 equals 3 ma. Call that equation 3. And if I now use these two equations together and I subtract, okay, if I subtract them, then the 3 ma's will become 0. I'll subtract them this way upwards. 3t minus t is 4t, and I'll have minus 3 mg minus 3 mg over 5 minus 9 mg over 5 will give you minus 12 mg over 5. And then I can find the tension. I'll have 4t is equal to 12 mg over 5. So T divided by 4, you'll end up with here 3 mg over 5. And there we have the answer to part A. And I'll do part B. Okay, so now for the next part of the question, which is part C. Okay, which I have prepared on the other side. So T, the tension in the string was 3 mg over 5. Okay, so now we're asked here in this question, let me just write down what we found from the last part. I think we're going to need it here. Okay, we found that the tension is equal to 3 mg over 5. Okay, so part B says, state where in your working you have used the fact that the string is modeled as being light. Okay, so basically what we did is we ignored the weight of the string. Okay, we didn't take the weight of the string into account. That's fine for the answer. It's a 1-mark question. Okay, part C, find the magnitude of the force exerted on the pulley by the string. So we know that there's a tension acting in this direction and there's a tension acting in this direction. Sorry, what am I talking about? Wrong way. There's a tension acting in this direction and there's a tension acting in this direction. This tension is what's pulling the particle, and this tension here, which is opposing this particle from moving, so it's providing like a resistive force. Okay, so basically those are the tensions that are acting on this particle, the tension acting this way and that way. Okay, now this angle here is alpha, so we're going to find the resultant force that's acting on the pulley. Okay, now on the pulley, see what if we think about it, this is the tension acting on the particle here, and this is the tension acting on the particle here, on the string. Now there's also going to be a tension acting next to the pulley in the opposite direction in the string. There's going to be a tension acting in this direction, pulling on the pulley. Okay, and similarly here, there's going to be a tension acting, pulling on the pulley. Okay, if we just consider, we're considering the pulley. So if we consider just the pulley, if we consider the pulley alone, okay, then you've got basically these two forces acting, something like that. They're both equal in size. You've got a tension acting this way and a tension acting that way. So there's a pulley here, and those are the forces acting on the pulley. Okay, and they're both equal in size, and we know that they're equal to 3 mg/5. Okay, so we want to find the magnitude of the force exerted on the pulley by the string. Okay, so we're going to find its magnitude. Okay, so we know basically the magnitude of the force is going to be somewhere acting in this direction here. Okay, there will be the resultant force over here. Okay, that's going to be its direction. Now, there's different ways we could deal with this question. But one way we can deal with it is by using like you can say the vector geometry. So what I could do is I could draw the force, the tension acting this way. Okay, that's the tension acting in one of the strings. All right, and then I can draw the tension acting in the other string. Okay, where this one ends. Okay, so I can draw, for example, so I'm going to draw this tension, and then where this ends I'll start the next force. Okay, something like this. All right, now what I know is that these two have the same magnitude. Okay, and the resultant force is going to be this force over here. This is the resultant force, call that R. Okay, I need to find what R is. I know that this is 3/5 mg and this is 3/5 mg. I need to find what R is. Now, what I need to do is to work out how I'm going to figure out what these angles are in this. Okay, so if you think about it, okay, let's just draw the forces around here and so you'll see what's happening. That's like the line of action of one of the forces, okay, which is the force over there. Oops. Which is the force over there. Okay, that's like your tension up here. And this is the line of action of the other force. Okay, I'm just going to draw that same diagram but over here so we can see what's happening. We can see that, you know, there are certain angles to each other, and that angle is alpha. So this angle here is actually alpha. You can see that from here if we draw the forces on this side. Okay, so that triangle of forces gives us this diagram here, and I know that this is 3/5 mg, as is this. But for now, I'll just keep it as T. If I want to find the resultant force, this is a non-right angle triangle, okay, I can use the cosine rule. So I can say that R squared is equal to T squared plus T squared, these are the two sides and the angle between them, minus 2 times T times T times cosine of the angle between them, cosine alpha. So you're left with R squared is equal to, that's 2T squared minus 2T squared times, now the cosine of alpha was, if I remember rightly, 3/5. Cosine of alpha is 3/5, so we don't actually have to know or find the actual angle, we can use the ratio again. So cosine alpha is 3/5, and this will help us get a more exact type of answer. Okay, let's move this down. Okay, so let's just simplify this. So you got R squared is equal to 2T squared minus, that's 6 t squared over 5. So r squared is equal to, now that's 10t squared over 5. That's 4t squared over 5. So therefore r is equal to 2t over root 5. Okay, so now we have the reaction force is 2t over root 5, so we've got to find it. We know what T is. T is 3 mg over 5. We found that in the last part of the question, in part A. So now we can say R is equal to 2 over root 5 times 3 mg over 5, which is 6 mg over 5 times root 5. But we shouldn't leave it as root 5 here because it's not rational. So it's best to rationalize the denominator. So we'll end up with 6 times root 5 mg. It's better to put the root 5 at the end. 6 mg times root 5. 6 mg times root 5 over, and you have 5 times 5, which is 25. Okay. Now these answers that I've left in this question, I've left them in terms of mg, and that's absolutely perfectly fine. The question does not mention to leave them in exact form. If they did, then we would have to leave them like this. But if you want to use g as 9.8 and calculate them in terms of m only without the g, you could do that, and you could leave your answers rounded to 2 significant figures or 3 significant figures. That's perfectly fine. I just prefer to leave my answers in exact form, and that's absolutely fine in this question. Okay, these questions don't tell you to round it. If the question said give your answers to 2 decimal places or give your answers in exact form, then you have to do it accordingly. If it doesn't mention anything, then it's up to you. But when you round, when you use g in your answer, you should leave your answer to 2 significant figures, and 3 significant figures is also acceptable. If you did not use g in your question at all, then 3 significant figures if you're going to round the answer. Okay? If it says exact form, then you don't round it, you leave it in this type of form. If it doesn't say anything, then it's your choice. Okay, so thank you for watching.